Welcome back to Cloud 42. I'm James, and today we're going to finish up the wheel arbor for the Toolpost grinder. I think all we have left to do is poke some holes in it for a spanner wrench, and then given that I've only got two hands, I think I'd also like to make a tightening fixture for the vise, just to make it a little bit easier to change the wheels without dropping anything. This is going to be part 21 of the Toolpost grinder build series. As always, if you haven't seen the other parts of the series, there is a link down in the description to a playlist. Let's go over to the mill and get started. Okay, this is the arbor, and I need to poke the holes in the back of it. And what I would really like to do is I would really like to just set it on parallels and mount it in the vise this way, then center up on it, poke those holes, then I can remove this part, put the flange in, and poke the holes in it without changing the setup. The problem is that because this has the register and the screw boss sticking out of it, when I put it in there back against the V-jaw, there's not room to actually get a parallel in behind there. It's just like a 1/16 of an inch short. You know, I could maybe face off the aluminum soft jaws or something to make it work, but I think I'm just going to end up doing this in two setups. So instead of setting it down in there, I'm going to grip it by the shaft and do it up here. Now these V-block vise jaws are just aluminum. I just made them actually on this mill, and they just close on this and grip it, and that will be totally sufficient for putting some holes in it. First thing we need to do is actually center up so that we have a 0 on the center of this so we can put the holes equidistant on each side. And for that, I'm going to use a dial indicator. Bring the mill down here and just see how close we are. Oh, we're not even close. Let's bring that in. Try that. There we go, we're about -1.5, about -1.5, 1.5, 1.5. I'm going to call that 0 in X and Y. And we'll worry about Z using a quill. Okay, so the space between these is 1.1 inch, so that means we need to go 550 thou on each side. So G0 X 0.550, and that'll put us in position for the first hole. Now I'm going to start with a spotting drill. Even though the torque on this is going to be fairly light, I'm still going to torque it down with the wrench. Make sure we're lining up in the right place. And it looks like we are. Just want to make sure I don't make contact with the taper. And it looks like we're going to be just fine. Okay, so let's power this up. Let me get a little bit of coolant going here, and we'll put a little divot there to start the hole. After first putting the mill in gear. Okay, we're going to take out most of the material from the hole with a 31 drill, but because I don't trust a drill to actually go on center, I'm going to come back with a 5/32 end mill and actually make the hole cylindrical and put it on location. But I'm going to use the drill to remove most of the material so that I'm not asking an end mill to remove that from the center. Now, this hole needs to be, the tip of this drill cannot go more than 150 thou deep, so I'm going to use the quill readout. I've got a 10 thou shim here. I'm just going to come down and touch that and then zero it, and then I'll go to 160 thou. $110, $120, $130, $140, $150, $160. Okay, let me swap this out for a 5/32 end mill. Now this end mill I have modified, and the reason is because when it comes down here on the side for that hole, this has a 3/8 inch shank, and the width of this shank was enough that it was going to strike the side of the taper. I didn't want that to happen, so I ground the shank down. I just chucked this up in a tool grinder. It was a Deckel tool and cutter grinder, and just ground this off. I set it to 8 degrees, which is the same as this taper, and I just spun it and ground in there until I had generated enough relief. Now again, I don't want this thing to actually center cut, so what I'm going to do is I'm going to go down. I went to 150. I know that the tip of that drill is about 30 thou, so I'm going to take this down to minus 120, which, because I'm using a 10 thou shim, is going to be 130. So let me zero it out on the shim. 0. Now we'll take it down to 130. And that's it. Now we've got nice little pin spanner holes in there. Let me see if my countersink will fit. It won't fit without striking the taper, so I'll have to do those by hand. Or, better yet, let's deburr those using the center drill, or the spotting drill. Okay, I'm happy with that. They go all the way down. You can see the drill point is still down in the bottom. Maybe you can't. The drill point's still in the bottom, and there's a little land around it, so I went just about as far as I could while still keeping the hole clean. Now I'm curious. Let's see what size the hole actually came out. Well, I'm expecting about 157. Let's try a 157 pin, and it goes in easily. 159. 160. Yeah, that's about it. It's just about 160. Yeah, 160 is tight. 159 goes in easily. So how close did we get? .532 should be 156, and we're about 3 thou oversized, which is fine, and that's going to be due to run out and other factors here. I'm happy with that. Since I'm going to be making the pins, as long as I know the size, it should be fine. And having them be just slightly oversized to take a 5/32 pins is no problem. Okay, let's get set up and do the flange. Get that a little snug. And then tap it down just to be sure. Okay. Now, unfortunately, since this is in a different location, we now need to zero up the quill on it again. And we're just going to use the chamfer around the side. Okay, 1.5, 1.25. That looks like about 2, and that looks like about 2. Okay, I think we're good. It's 50, 75, 110, 120. Now this one I don't have to go grab the spotting drill to deburr. I can just grab my little Noga deburring tool. Just take the edge off of that. Of course, this wouldn't fit around the taper, so I couldn't use it before. Okay, that's that. Let's get set up and make a fixture. Okay, you've seen this piece of aluminum before. This is actually the block of aluminum that we used in the lathe to hold the hold the arbor as we were cutting the taper. And since I'm using this in a 3-jaw chuck and I've now pulled it out of the lathe, it's no longer concentric, can't use it for anything else, so we might as well use it for this tightening fixture. So I'm just going to drop it in here. And then we just center up on it. And I'm going to do this with an edge finder, and I am going to run the edge finder against these angled sides, and it ultimately won't matter, won't be quite as precise because of the angle, but it will center it up. I'll just do it on both sides and on the jaws. Okay, the first step is to take out the bulk of the material in the taper, and to do that I'm going to use a 1/4-inch 3-flute carbide end mill. Let me grab that tool and put it in. Definitely tighten it down. That looks better. Okay, that feels a lot like a taper. Okay, the next tool is a 1/4" ball nose end mill. And the purpose of this is just to go down and smooth the inside of the taper. Well, that looks pretty nice. Curious to see how it fits. Oh yeah, that is beautiful. I think I was estimating that it would sit 100 thousandths high. Let's see how high it really is. There's a 101 block, and it just barely skates in there. If I press down, it doesn't. So, looks like we hit it right on the nose. Okay, this will be the same drill as before. Pun intended. We're going to spot them, drill out the bulk of the material with a number 31 drill, and then come back and plunge with the end mill to actually put the hole in position and on size. Now the number 31 drill to remove the bulk of the material. And now the 5/32 inch end mill to bring it to size. Taking this really slow since it is a 4-flute. Okay, that is it. We are golden there. Let's see what size those holes came out. We know how they came out in the steel. They came out around 160. Let's see how they came out in aluminum. Here's a 159. Fits in easily and makes a little pop. 160. Goes down, but it's tight. So these are just about the same size, 160. Okay, next thing we need to do, now that we know the diameter they came out, is go over to the lathe and make a couple of pins to go in there. Okay, I've had to think about this, and before I put any pins in these holes, I want to make sure that I actually have a hole all the way through so that I can punch them back out if needed. So I'm just going to take this same number 31 drill and push it through, and then I'll probably ream it to an 1/8 inch just because this is the right drill for that and I have the reamer handy, and that seems like the easiest way to get this job done. Okay, this is just an 1/8 inch reamer. This is just a piece of 1/8 inch drill rod, just to make sure I really can pass it through there. Yeah, no problem. That'll make it easy to push out the pins later if I need to. Okay, now we'll go over to the lathe and make the pins. Okay, I'm set up here in the lathe. This is a 1/4 inch W1 drill rod, and the first thing I'm going to do is just face it off to length. I've got this Kyocera carbide insert in here, and I'm running at 2400 RPM. If I could run it faster, I would, but I can't on this lathe, so I'm gonna just face off the end until I have a clean end. Okay, now we're gonna bring about 1/2 inch of it down to 160. Okay, let's see where we are. 197, so which means we got 37 to go. About 19 per side. I'm going to start taking 5 thou passes because we're getting smaller. Okay, now I'm going to switch to 2 thou at a time. Let's see, where are we now? 173, headed for 160, which is 13 thou to go, which is 6.5 per side. So let's take 2. And 2 more. See where that leaves us. I feel like I got something in here. Looks like 165.3. Then take a light 2 thou pass. leaves us 162. These means I need to take about another thou. Let's see if I can do that with the carbide. $159.6, $159. I think that is going to work. So we're ultimately going to glue these in. Yeah, I think that's going to work just fine. Okay, so now the last 200 thousandths I need to take down a little bit further to like 150. So let me take a little bit off of this. $153, so just a touch more. There's 149, that will work just fine. So now I just need to cut this off. Actually, I'm going to chamfer the tip a touch. And we're going to cut it off around 450 thousandths. Okay, right there. Try raising that slightly. That's a little better. Looks like we're still a touch below center, so I'll raise that slightly for the next one. Okay. Now I just have to figure out where the part went. There it is. Okay, that looks good. I'll file the back, of course. Let me make another one. Well, this is the fixture in the vise, ready to put the pins in. You can see the inside surface of this taper. I'm really happy with how that turned out. Let me hold up the camera here and see if you can see the ripple in the side. So I took it 30 thou depth at a time with the ball end mill, and that left, you know, like maybe 4 or 5 tenths of surface texture, which is going to be just fine for this. Now I noticed something after when I first tested this when it was in the mill vise, it fit great and the taper kind of even locked a little bit. Now that I have it out, I'm detecting just a little bit of rock front to back, just a couple thou. And side to side, there's nothing. So it's tighter in this direction than in this direction. And I was thinking maybe it was backlash in the mill or something like that, and then I realized I distorted the part. I squeezed it this direction, squeezed these sides out, these sides in, and then milled the whole round, and while it was still in the vise in the mill, it worked great. And now that I've taken that pressure off, I have a little bit of play. Now, it doesn't matter at all for this application, but I learned something there. That an aluminum part this size and shape with a hole through it, with the power you have in a mill vise, you can easily push it out around. So in this case, it's not going to matter at all. And if it really did matter, I'd just squeeze it a little harder in this vise and bring it back into that shape. So let's put in the pins. So I got the pins here, and I'm going to put them in with a little bit of green Loc-Tite 609 permanent retaining compound. Now, if I ever do have to get these out, I can of course get them out by heating it up and tapping it through with a drift from the back. Let's see here. Come on, tip's clogged. Don't need too much of this. Okay, and the other one, same drill. Little 609. Then we'll just use the vise to seat those. And there they are. See how it fits. So we've got the two pin spinner holes on the back here. Should fit right under those pins while this drops into the taper, and that is perfect. I could not be happier with that. So now we can drop on a wheel and tighten down the flange with a spanner wrench, except I don't have a spanner wrench. We will work on making one of those next time. That's it for today. If you're enjoying these videos, please comment, let me know what you like, let me know what you want to see more of. Also, be sure to subscribe so you won't miss future videos. Thank you for watching.